my dear learners, for this course on dynamics of machines. In this module 1, we were discussing on static force analysis and dynamic force analysis. So far we have solved 4 numerical problems on static force analysis. Continuing our discussion, today I am heading to solve the final problem of our discussion, that is 4-link mechanism coupled with slider crank mechanism. So the problem number 5 of our discussion on static force analysis is...
Moving for the final problem number 5 states that for the static equilibrium of the mechanism shown in figure, find the required input torque. The dimensions are AB is equal to 150 millimeters, BC is equal to AD, which are equal to 500 millimeters, DC is equal to 300 millimeters, CE is equal to 100 millimeters, and EF is equal to 450 millimeters. And this is the diagram we have. If you observe, we have both 4-bar mechanism and slider crank mechanism. Nothing big here, just we should start the problem from link 6, because we know force on link 6, which is 250 newtons, and keep solving by applying the concept which we have learned. As usual, in first step I should draw the problem to the scale. So in order to choose the scale, the maximum dimensions which I am observing here is 500 mm. So therefore I will choose a scale of 1 centimeter is equal to 50 millimeters. If I choose 1 centimeter is equal to 50 millimeters, the maximum length I am going to get is 10 centimeters. So choosing that scale, let us start solving this problem. That is, I will choose a scale of 1 centimeter is equal to 50 millimeters. So if I move for problem number 5 and list out the data given, we have AB is equal to 150 mm, and we have BC is equal to 500, and AD is also equal to 500 mm, DC which is equal to 300 mm, CE which is equal to 100 mm, and we have EF is equal to 450 mm. Now in order to solve this problem, I want to choose a scale. I will choose a scale for dimension as 1 centimeter is equal to 50 millimeters. Choose a scale of 1 centimeter is equal to 50 millimeters, and also scale for force. I will choose the scale for force as 1 centimeter is equal to 50 newtons. Now I want to rewrite the problem or reconstruct the problem as per scale. So if I reconstruct the problem as per scale, first we have, this is D, AD is 500 mm, which means 10 centimeters. So first let me draw AD, which is 10 centimeters. I will draw AD measuring 10 centimeters. Drawn. AD centimeters, which is fixed link. There is link 1, and at A we have 75 degree as a crank angle specified for us. So for an angle of 75 degrees, we have the length of crank AB, which is 150 mm. 150 by 50 is 3 centimeters. So drawn for 3 centimeters. This is point B. Now he has given BC. BC length is 500 mm and DC length is 300 mm. So therefore I want to cut an arc for these two dimensions. So hence, if I cut an arc for these two dimensions, we have, first is AC. B to C is 500 mm, which means 10 centimeters as per our chosen scale. So therefore I'll cut an arc for 10 centimeters. Done. I've drawn an arc for 10 centimeters. And C is 300 mm. 300 mm divided by 50 is 6 centimeters. So for the chosen scale, 300 mm is nothing but 6 centimeters. So I got point C. So this is 6 centimeters. And this is 10 centimeters. Now he himself is stating that DE, that is CE, is 100 mm. So 100 mm is 2 centimeters. So extend the line DC 200 mm forward. Extend it 200 mm forward to get point E. Now from the horizontal I should measure 200 mm. 200 mm is nothing but 4 centimeters. So from the horizontal I should measure 4 centimeters. 4 centimeters and fix up and again an horizontal. So from the horizontal I should fix up one more horizontal at 4 centimeters. Done. I have taken a reference of 200 mm, which is nothing but 4 centimeters. mm for the chosen scale. Now EF is specified as 450 mm. So 450 by 550 is 9 centimeters. So for the chosen scale I should pick 9 centimeters. I picked 9 centimeter and intersect this to get the slider. So if I extend this horizontal, I'll get the slider. So I got the point F. This is link 6. This point is F. E to F I have joined, and we have a fixed link, that is link 1. On this slider we have the force F acting. It is 250 Newton. Now to avoid confusion, let us take it as P, which is equal to 250 newtons. So this is the given problem for us. So I have reconstructed the given problem as per scale. This is link 5, this is link 4, this is link 3, and this is link 2, and this angle is 75 degrees. Now if I observe, I should start solving the problem from link 6, because at link 6 force P is equal to 250 newtons. So directly consider link 6. So if I consider link 6, we have, considering link 6, if I consider link 6 is a slider. So forces acting are F1 on 6, F5 on 6, and force P. So at F all the three are meeting, as we know that for a slider the support reaction or force acting from the fixed link is always vertical. So therefore the free body diagram FBD for a slider is very easier one for us. We know line of action of P, which is horizontal, Draw the line of action of P which is horizontal. We know line of action of force F16. For slider it is always acting vertical. And F56. So look at link 5. If I look at link 5 is a 2 force member. 5 is connected to 4, 5 is connected to 6. So for 2 force member, link or parallel to link is the line of action. So therefore draw a parallel line to link 5. Drawn parallel line to link 5. So this is F56 line of action. So this is the line of action of P, F16 and F56. So line of action is parallel to link 5. This is because of the reason link 5 is a 2 force member. Now if I draw force polygon, I can get the solution. So let me quickly move ahead and solve for force polygon to get the solution. That is, as I said, to draw the force polygon, first we should lay down the known force. Known force is 250 Newton, which is turning out to be 5 centimeters, because scale chosen for force is 1 centimeter is 50 newtons. So force polygon for link 6 will be, first I should draw force P. Force P is known to me, which is 5 centimeters horizontal. Let me take the book as a reference. Draw 5 centimeter horizontal line. So I drawn 5 centimeter line. This is our force P. Here. Now we know that line of action of F16 is vertically upwards, but I don't know what is the magnitude, so I will draw arbitrarily vertical line. Now we know line of action of F56, which is parallel to link 5, so therefore I will draw a parallel line to link 5. So I use this as the closing side and draw a line to link 5. So we got the force polygon. This is F16 and this is F56. Let us take this as point B. So therefore now the magnitude will be F16 is equal to line length AB into scale for force. If I measure the line length, I'll get line length AB as 2.2. centimeters. To scale for force is 50. If I go for F56, it is line length BO into scale for force, line length BO 5 centimeters. .5 into 50. So if I solve, I get the answer as 2.2 into 50, which is 110 newtons, and 5.5 into 50, which is 275 newtons. So this completes the analysis of link 6. Next move for link 5. Next, consider link 5. If I consider link 5 is a 2 force member because it is connected to link 4 and it is connected to link 6. So no calculation is necessary for 2 force member. So just show it. And we know link 5 length is 9 centimeters. So I draw 9 centimeters a parallel line to link 5, which means I have link 5 here. This is point E and this is point F, and I can show the forces neatly here. So this will be the force acting on link 5. This is line of action of F4 on 5. This is line of action of F6 on 5. And the calculation is easy, that you people already know. For two force member, F4 on 5 must be equal to F5 on 4 must be equal to F6 on 5 must be equal to F5 on 6. F5 is already known, so hence all are equal to 275 newtons. This completes link 5. Next go for link 4. So if I observe link 4 is a 3 force member, we can see here, because link 4 is connected to link 5, link 4 is connected to link 3, and also link 4 is connected to link 1. So for link 4 we have 5 on 4, 3 on 4 and 1 on 4. So next, moving for link 4, that is, if I consider link 4, we have the forces, magnitude and line of action. Link 4 is a 3 force member. It is connected to link 5, it is connected to link 3, and it is connected to link 1. Magnitude of 5 on 4 is already known to me, which is 275 newtons. 3 on 4 is not known, 1 on 4 is also not known. Coming for line of action of 5 on 4. If you observe, link 5 is a 2 force member, hence link itself is a line of action, right? So therefore I know line of action of 5 on 4, it is link 5 are parallel to link 5. Similarly, if I observe link 3 is also a 2 force member. F2 on 3, F4 on 3 will act, hence link 3 itself is the line of action for F3, 4. Since this is also known, link 3 are parallel to link 3. Now this is not known to me. I should find F14. So in order to do that, I should use free body diagram. This you people already know. So therefore draw free body diagram. So to draw free body diagram, I want the link 5 to be reconstructed, link 4 to be reconstructed. Now to reconstruct link 4, since I am doing a different page, let me use the angle. Let me use this angle. The angle is turning out to be 85 degrees. So this is turning out to be 85 degrees for me. So at an angle of 85 degree, I should draw a line of DC is 300, CE is 100, total it is 400, which means 8 centimeters. 85 degree, 8 centimeters I should draw. So let me redraw it. 85 degree, 8 centimeters. The horizontal from the book itself. So now I will mark 85 degrees, 8 centimeters. /85 degree, 8 centimeter marked. So this is link 4 reconstructed. This is D, this is E. This angle is 85 degrees. Now we know that F54 line of action is link 5 itself, so therefore let me measure the angle of that also at E. If I measure the angle, it is at an angle of 70 degrees. So therefore mark a line at an angle of 70 degrees at E. So measuring 70 degrees, we'll get the line of action of link 5, that is F5 on 4. So this is line of action of F54, which is parallel to link 5. Now I want F34, which is link 3, acting at C. So C is 300 mm, that means 6 centimeters from D. 6 centimeters from D. So this is C, 6 centimeters from D and 2 centimeters from E. Correct. Now I should draw a line parallel to link 3, that is at C. Let me measure the angle, that sounds better. So at C, let me measure the angle. The angle is turning out to be 68 degrees. 68 degrees. 68 degrees. So therefore draw 68 degrees here. Degrees drawn. So this gives us the line of action of force F34. So this gives us line of action of force F34. Line of action of force F34, which is parallel to link 3. At link 3 is connecting with C. So now we know that I can join these two if I extend forward. So therefore join these two. Extend forward, join these two. So these two forces are joining here. This is nothing but point of concurrency. I got point of concurrency. Then another force should join here and pass through D. So therefore connecting these two will give us line of action of unknown force. So I will connect POC to D. So this will give me the line of action of unknown force. So to the center force, outer force should act outward, opposite to that. So this is the direction of remaining two forces. And also F54 is opposite to F45. That also I can use here. So now we know line of action of unknown force is also known now. Line of action of F14 is also obtained. Now I can solve the problem by doing force polygon. So just draw the force polygon and finish off the problem. So move for force polygon. If I move for force polygon, we have chosen a scale of 1 centimeter is equal to 5 newtons, whereas the force F54 is completely known in direction as well as its magnitude. F54 is 275 newtons. So 275 divided by 50. 275 divided by 50 is 5.5. So first you take 5.5 centimeter. So let me draw 5.5 centimeter and lay down this force first. 5.5 centimeters. So drawn 5.5 centimeters. So this is actual force F54, which is 275 newtons. Okay. Now I should use these two forces and close it. Let me close the force polygon by drawing parallels. and this will become the closing side. So this is B. So now I can measure what is the force F14 and what is the force F34. That is F34 is equal to line length AB into scale for force, because it is force. Length is 7.5 centimeters, so therefore 7.5 into 50. F34 is turning out to be 7.5 into 50, which is 375 newtons. Find out F14. F14 is BO into scale of force. BO is measuring 5.1 centimeters into scale is 50. 5.1 into 50 is 255 newtons. 255 newtons. So this completes complete analysis of link 4. Now let us move ahead for link 3. Next, considering link 3. So if you consider link 3 is a two force member. You can see here, if I consider link 3 is connected to link 2 and link 3 is connected to link 4. Hence the forces acting on link 3 are F2 on 3 and F4 on 3. So whenever you have a two force member, no calculation is there, just you draw a line parallel to link 3. So we have a line parallel to link 3 already here. We make use of that directly. So we have a line parallel to link 3. Link 3 is 10 centimeters. Link 3 is 10 centimeters. Now I will represent the forces acting on it. If I represent the forces acting on it, we have two forces, F2 on 3 and F4 on 3. Two forces are line of action of F2 on 3 and we have line of action of F4 on 3. Now we know that F23 must be equal to F32 must be equal to F43 must be equal to F34. We have already calculated F34 just now, which is 375 newtons. Hence we know the force, which is 375 newtons. Now moving ahead for the final step, that is solve for crank. Moving for link 2, that is for crank, we have the forces acting on it are 1 on 2, 3 on 2, and we should find what is the torque. We know that F32 is coming from link 3. Link 3 is a two force member, hence link itself is the line of action for F32, whose magnitude is also known to me. Whenever we solve for crank, we should reconstruct the crank. So therefore let me reconstruct the crank first. So if I reconstruct the crank, first, that is, we have the crank angle given 75 degrees specified. So measure 75 degrees, which is specified in the question. Measured 75 degrees, and crank length is also known. Crank length AB is 150 mm, that is 3 centimeters. So draw 3 centimeters at 75 degrees. Draw 3 centimeter at 75 degrees. So I drawn 3 centimeters at 75 degrees. This is A, this is B. So we are done with crank. Now we know it is acted upon by two forces, in which F32 line of action is known, which is link 3 parallel to link 3. So therefore I'll draw a line parallel to link 3 at B. We know that F12 should be parallel to F32, so therefore draw another line parallel at point A. So this is line of action of F32, which is parallel to link 3, and these two are parallel to each other. And we know that F32 is acting like this, and F12 should act like this. So this is line of action of F12. Now we measure the distance, perpendicular distance. Let me draw a perpendicular and measure the distance. So if I do that, drawn a 90-degree line, and I will measure what is the distance between them. So I drawn 90-degree line. Now if I measure the length of this 90-degree line, it is turning out to be 2.5 centimeters. So therefore we got H as 2.5 centimeters, which is equal to 2.5 centimeters. Hence we know that couple is equal to F32 into H into scale of dimension. F32 is 375 newtons. I got 2.5 as H, and scale for dimension is 50. Hence 5 into 2.5 into 50, which is 46,875 Newton millimeters counterclockwise. Therefore the torque T2 for this problem is 46.875 Newton meters clockwise. So this is the solution for this problem. So what we have done is that we had the problem of 4-bar mechanism and slider crank mechanism. Using the scale, I have redrawn the problem. So this is the problem which I have redrawn. So once I reconstructed the given problem as per scale, I started the problem from link 6. When I went for link 6, which is a slider, I know all the lines of action. I drawn the free body diagram. Using force polygon, I found out what is the unknown forces. Next I went for link 5. When I went for link 5 is a 2 force member, no calculation is there, just I represented link 5. Next, coming for link 4 is a 3 force member, for which again I had drawn free body diagram and force polygon to get the forces. And finally I came for link 3, it's a 2 force member, and solved finally for link 2, and I found out the solution for this problem as 46.875 Newton meters clockwise.
So this is the complete solution of problem number 5. So this completes our discussion on static force analysis. In our next lecture, I am heading to discuss dynamic force analysis. That's all from this lecture. Thank you all.